Hello, welcome to Microsoft Build 2017. My name is Chris Cortez. I'm a program manager on the development platform, and I'm here to talk to you about what's new in multitasking in the Universal Windows platform. Now, before we jump into all of the great new aspects of multitasking that we've been working really hard on since last build, let's first stop and talk a little bit about some of the basics. So we're going to talk first about the background task and the application life cycles and what those two processes can do for you with running in the background. Then we'll jump into some code with the new multitasking scenarios that are available to you in the Creators Update and in the upcoming release. Then we'll go a little bit into what the new user controls are and how they are available to device users on desktop and mobile, and how you as a developer can have some best practices to take a look at what the user has chosen and react accordingly. So like I said, there are two different types of processes that you will be working with in UWP if you're looking to do background activity. The first one is the background task. Now, the background task is a completely headless process. That means that there is no UI associated with it, and it is going to be running silently in the background without any presence in, say, the taskbar on desktop or even in the back stack for mobile or other OS editions. Now, when you are running a background task, the very first thing that you do is you run it. A background task is rather simplistic in its model in that you have a background task run method, which is initiated, and then it will run to completion. Now, in an ideal situation, your background task run will start up, will run, and will complete before it hits any type of resource limitations. Now, we find that this isn't always the case. Sometimes when your run method either runs a little too long, it could hit an execution time exceeded issue, or it could hit some type of memory or other resource issue. Now, when that happens and the system decides that your background task needs to be terminated in some way, well, you are actually given the opportunity to do work during a cancellation event handler. So the cancellation event handler will fire and will actually give you an extra 5 seconds. So generally, you get about 25 seconds of wall clock time for a default background task to run. There are some other types of background tasks, such as an application trigger background task or a maintenance trigger background task that can run up to 10 minutes. But generally, you'll get about 25 seconds for most, say, Bluetooth triggers or system triggers or any other types of these default triggers. And then you'll get that extra 5 seconds if you've registered for this canceled event to then clean up any work that you might need. So cleaning up for your app could be different from other apps, but generally it includes closing database handles, finishing up that last little bit of network communication to say that you're ending the session, anything that gets your app completely shut down and closed and ready for the next instance or process of your application to actually come up. Now, when you're implementing a background task as a separate process, you're going to actually implement it as a separate Windows runtime component. That separate runtime component is going to actually be a separate project within your solution, and you're going to implement the iBackground task interface. Now, the other option that you have to run work in the background is actually to run it directly within your application. Now, starting in the anniversary update, you can run background activity in process. So previous to that, you had the same running states of running, suspended, not running, and the callbacks of launched, on activated, suspending, and resuming. But in the anniversary update, we've introduced entered background and leaving background. So your app could theoretically start by being in the not running state, get activated either by, let's say, a user launching your app or by having a trigger activating your app into the background silently. Then you could start by running in the background, and if it was a launch by a user, then you would move into the foreground, and you as the app developer would receive a leaving background callback. Now, let's say you are doing work in the foreground and then you need to move away into the background. Well, if the user minimizes your app on desktop, for example, then you would receive an entered background callback. And if you are doing work in the background and have specified that you want to do work in the background, then you'll be running in the background for a while. Once that work is completed, then you'll move into the suspended state, and you'll still receive that same suspending callback so that you can do any kind of completed work. So at that point is where you would want to save user data, where you would want to ensure that if your app did ever get terminated and moved into the not running state, then your app is ready to start up again. Now, there is a scenario in which your app could be running in the foreground, then running in the background, and then could actually continue to running in the foreground again. And we'll take a look at what this looks like with extended execution a little bit later. So now let's jump into some of the background scenarios. The first thing that you need to know when working with background scenarios is how to activate your application in the background. And that's done using triggers. Now, there are a plethora of triggers available to you as a developer to activate your application in the background for all kinds of scenarios. A new one in the last release is the GAT service provider trigger as part of the set of Bluetooth triggers. There's a set of sensor triggers for any kind of USB connected or even other Bluetooth or RF kind of connected devices. Set of network activity triggers if you need to receive a push notification or open up a socket and keep it open even while your app isn't in the foreground. There are also a lot of triggers to work with other forms of UI, such as the toast notifications, or work with other local data sources. Say if you're doing some type of contact syncing and you need to know as an app when your users update contacts in their other contact stores or appointments or email or any other types of file updates as well. And then there's also a set of system triggers. And these are generally around what the system is doing at the time. So for example, if the user moves away or if the user comes back to the device, if there's some type of power state change in whether the battery is available or not, or whether there's an internet connection or not. So we've seen that there are a ton of different triggers. So let's look at what these different triggers look like when implemented in your project. So here we have a device watcher trigger. And now, as you can see in register all tasks, what you do in order to get a task up and registered with your app is to use the background task builder. Now, the background task builder is going to be the container for all of the attributes of your background task. So in this case, we're setting the task name. We're saying that yes, network is requested so that when your background task comes up, you'll be able to use the network. We're defining the task entry point, which is the entry point in your application that will then be activated. We're setting the specific trigger, to this case be a device watcher trigger, and then we're hitting register. Now, when we look into the solution, we can see that this is an out-of-process background task. And we can see that because it is a separate project within the larger solution. So you can see here we have the tasks project, and within that we have our notifier task. So within that notifier task, we have the implementation of the iBackground task interface, where we are holding a deferral. We are then registering for that cancellation callback. And then we're checking to see if the device watcher found some new events for us to actually do work on. And if it did, then in this case, we're just going to pop a toast. So now let's take a look within the app what that actually looks like. So here we have our sample digital audio workstation. So let's say that we need to actually activate and tell the user, hey, open up my app when you connect a USB peripheral that you're going to, let's say, record from a 1/4 inch input or an aux input, some type of other audio input from. So what we're going to do now is by clicking this, we're going to register that device watcher trigger. And in this case, I'm just going to plug in my phone as a portable storage device, but you could plug in other types of audio devices as well. And when we put that in, we'll wait for it to enumerate on the device. And we'll be able to see it pop up. And here we see that we have an out-of-process background task that has been initiated. Now, if we want to, let's stop that for a sec. And let's go back to our project and take a look at what it looks like to create an in-process background task. Now, we talked about the background task as the separate process that runs outside of your application. Now we're going to put that inside of the application that runs in the foreground. Now, there are a lot of benefits to that, primarily in that you can share code between your triggered task work and your foreground application, but also that you don't have to do a format of inter-process communication. And if you're not familiar, working with inter-process communication can be a very difficult and time-consuming method in order to actually have your triggers communicate with your foreground app. So in order to get this trigger turned into an in-proc task, we're going to remove the task entry point. Now, if this had a manifest entry, we could also remove that because you don't actually need a manifest entry for in-process background triggers. So when we remove the task entry point, what that actually does is it automatically brings it to the default task entry point. Now, that default task entry point then points towards a background activated callback instead, which will activate your app directly. So in this case, once again, we're going to register our trigger. We're going to plug this in. We're going to wait a while for the device to enumerate. And then what we'll actually be able to see is instead, hey, look at that. This now did an in-proc background task activation. So the other part that I talked about that we need to make sure to do when we're doing an in-process activation is actually to create the background activated callback. And so now here we see that the background activated callback is actually a protected overridden method that you can then add to and put whatever task you want. So in here, we've moved our notifier task object and put the entire class definition into the applications project, and then set that task to run when the onBackground activated event fires. So now, let us go and take a look at what it would mean to have multiple developers working on your app. So if you have multiple developers, or if you are using frameworks that have multiple sets of background tasks, you can start getting pretty high in number for the number of background tasks and triggers that your app is using. And this starts getting a little difficult to manage just using the common background task registration all tasks member. So what we've introduced in the creators update is that you can actually group your tasks so that you as a developer can specifically work on your set of tasks and another developer on your team can work on their own set of tasks and not accidentally step on each other's. And so what that means is in background task registration, instead of registering all tasks and unregistering all tasks, instead we're going to go down here and we're going to take a look at how we've now grouped tasks. So in here, we've now identified a task group ID, which is a unique identifier for your task group, as well as a friendly name, just so that it's easier for you to debug instead of having to read a GUID. And you just add that to the registration process. So all the same pieces of the registration are here, and then you just have the additional task group member. So now, in our main page, what we're going to do is we're going to switch over from registering all tasks to registering specifically my tasks. And when you do that for an in-process background activation, what you'll actually see is that over here in the app.xaml.cs for a CS project, we're actually going to register for a background activated event specifically for that group. So instead, we'll see all of the same functionality, but you get to choose where you want that activation event to be directed towards. And so if you want to have it directed towards your own kind of subclass or member somewhere else, you can do that while another developer on your team points all of their activations to a different location within your app project. So we took a look at moving that background task code into the main app project and out of that separate project. We looked at implementing background activated as the protected overridden method that you can now have as an activation within your application object. We've identified that it's now easier to create an in-process background task because there's no manifest entry required, and it's also no inter-process communication required, and you can also share more code by having it in your application process. And then we also took a look at those background task registration groups, which are introduced in the Creators Update. And here's a little bit of a consolidated view of that background task registration group. As you can see, like before, you have the ID, the friendly name. You're going to go take a look and find your background task registration group within that background task registration object. And if you don't find it, then you'll create your own and add it during that background task builder process. So that's how you activate your app in the background. But what if you have an activity that's already ongoing in the foreground and you need to move it into the background? Well, activity-sponsored execution is actually what you want to do for that. Now, in the anniversary update, we introduced background media playback. And with background media playback, all you have to do is add this capability to your application's manifest and just press play. You can use any of the same playback APIs that you would normally use for foreground activity, and it'll just smoothly run seamlessly into the background. So if somebody minimizes your app and you are playing audio through, in this case, the media player APIs, it'll just keep playing and your suspension will be delayed until that media is completed. So you don't need any of that background task builder registration code. You don't need any of that inter-process communication to manage the separate background task. It all just works within the same process. Now, extended execution is the way to get a generic type of activity running in the background from a movement from the foreground to the background. Now, in the same way, you can run while minimized, like you would do with a Win32 application, for example, using the unspecified or location tracking reasons. And if you're in a power-rich environment, or if the user has said that they will allow you to always run, then you can run without a time limit. Run as long as your application deems it's necessary. You can also run longer while in the suspending state using the saving data reason. Now, this saving data reason will allow you to run for up to 10 minutes. However, it could be revoked if there's a new activation that comes in. So let's say a user closes your application, you're trying to do some last little cleanup work in there and save some data either to a network share or locally, but then the user determines that they really need to come back to that app. Well, when they reactivate the application, that previous instance will come down, will be revoked, and then the new instance will come up. Now, extended execution ensures that you have good resource usage. There is a time limit for your execution when you're on battery power, and this extended execution is accepted into the Windows Store. However, what if you're not as concerned about good resource usage, and what you really care about is using the full properties of your device, and you don't actually care about getting into the Windows Store? Well, for enterprises and line of business applications, we've introduced a new capability. It's a restricted capability that won't be accepted into the Windows Store, but will be accepted into the Windows Store for Business. This is called Extended Background Task Time. Any background task that you are creating will now no longer have an execution time exceeded or idle task cancellation. You'll still be under the energy policies that the user has set, so we've also introduced a set of group policy and MDM policies that you can now remove those energy policies if you as an enterprise deem fit. So you can have a master switch that lets apps either forced allow to run them in the background, forced deny to never be allowed to run in the background, or to allow the user to be in control. And then you get 3 sub-policies that you can specify individual applications based off of the package family name and whether you want them to always run in the background, never run in the background, or if you aren't really too concerned about them and want the user to be in control. So, like I said, all of these policies directly map to user controls. Now, the user controls that are available for background applications are split up into privacy and into battery usage. So for the privacy controls, you can see here that within the Settings app, the user has the ability to turn on or off background activity for your application. Now, when the user does this, this has control of all triggers and controls all generic extended executions. And once again, this is overridden by group policy. So if a group policy is applied that says force allow all of my apps, you'll actually see an indicator on this page that says that this is being managed by your enterprise policy. The other level of control that users have is through battery usage. So this is also within the Settings application, but gives the user a little bit more fine-tuned ability to say whether I want the app to always run in the background, never run in the background, or be managed by the system, that is managed by Windows in this case. So the UI for this in the Settings pages actually looks different across OS editions. On the left is the desktop version, and on the right is the mobile version. However, they are still controlled by that same group policy, and you as the developer still get the same interface. And so let's take a look at what those interfaces look like so that you can tell what the user has chosen. So the background access status is how you can determine what the user has chosen in these interfaces, as well as what enterprises have chosen. So once again, you have always allowed, you have denied by user, and in the 2 middle ones, you have allowed subject to system policy and denied due to system policy. These are both the managed by Windows options that the user has. However, this is a more fine-grained look into whether at that current time, Windows is allowing your app to run in the background or not allowing your app to run in the background. You also have 2 other interfaces in the form of battery status and the energy saver status. These are useful in determining whether your device is currently in an energy-constrained environment, such as whether it's on battery or whether it's plugged into AC power, or if the battery saver functionality is either off or on. So let's take a look at how these actually impact whether you can run or not run in the background. Let's see, so let's go back to our app right now and take a look at our digital audio workstation again. So sometimes you'll also need to do some playback of your audio while you're adding or removing new components to it. And so that's where the same functionality of that background media playback works. So in this case, you can see we've just pressed play, and now we can actually have our background media playback going, and we can minimize, we can move around, do whatever we need to, and your background audio will just keep on playing. Not an issue. Well, now if you also need to do a generic type of processing, let's say in this case you need to compile your project down into a file, well, you can also do that. So what I'm going to do now is I'm actually going to unplug my laptop and show you that when I hit compile, oh look, we get this prompt. This prompt says that extended background activity is required to complete your request, but you as a user have set something within battery usage that does not allow this extended activity to actually occur. So let's click OK, and let's plug power back in again. And when we click compile again, look at that. Our extended execution has now begun. That's because the system has determined that we are in a power-rich environment. We are plugged into AC power, and there's no concern about the user's battery because we're still charging the battery while we're doing this background activity. And once again, you can minimize, do whatever you want, and it'll keep running. And let's stop that now. So let's also try out unplugging again and trying this compile step. And you see how we now need to go to the battery usage settings. And this will take you directly to the battery usage settings that we had shown on the slides. So here you can see the Build 2017 multitasking app. Right now it's managed by Windows, and if we turn that off, so now let's allow apps to run background tasks. So now we can see that apps are allowed to run background tasks. And if we press play, oh, look at that. Now we actually can run in the background. And that is because in that situation, I as a user said, yes, allow my apps to run background tasks and use excess battery, and I am aware that this app is using excess battery. So let's see what that looks like in the code now. So we're going to open up our extended execution helper and take a look at what it actually means to be long running in the background. So is long running, in this case, is a function that checks both that battery status that we talked about, as well as the background execution manager background access status. Now it's going to check and see, hey, did the user say, yes, I can run in the background even if I'm connected to battery? Or is the device connected into AC power and not in an energy depleted or limited state? And if we say, yes, I can run for long, then what we're going to do to start our extended execution is we're going to get an extended execution session. We're going to define the description and the reason, and then we're going to request that extension. And then you as a developer will be given either an allowed or denied state of that extension request. So that is how you run an extended execution for a long period of time as a generic type of execution or activity. You need to make sure that you are always testing this off of the debugger. You'll see that when you attach a debugger to any of your UWP applications, what will actually happen is that the debugger will remove all execution time limits from your application. And so in order to properly test those time limits, you'll need to make sure that it's always debugger detached. We saw how to create an extended execution session and how to request that extension. And then we saw how we can use background access status and the battery status to determine if the user has set the right choices for you as an app to run for a long period of time. And then if they haven't, how to actually direct the user to the settings app if needed. So now that we know how to run as long as needed in the background, start building. Create any type of background activity for any type of scenario that you can think of. You can also take a look at some of the other build sessions related to background activity, such as the new GAT service provider trigger on channel 9. And then you can also take a look at any of the GitHub samples or tutorials that are available on the next slides, as well as checking out Microsoft Virtual Academy online. And we would really appreciate your feedback. We're always checking user voice to hear what new features you would need to create some great new experiences, but we're also checking places like Reddit, Stack Overflow, the MSDN forums to make sure that what we have created is beneficial to you and what next steps we could do to make it better and create some really great user experiences while still making sure that users have excellent battery life and a very performant device. Well, I hope you had a great time. I know I did, and I hope you enjoy the rest of Build.